Welcome, and thank you for joining our webinar today on metal powders and alloys with ColdBlock digestion technology. I'm Craig West, the CEO of ColdBlock, and I'm pleased to be speaking with you today. Before we get started, I'd like to mention just a few details around how this session will run. The webinar is being recorded, and after this session is completed, you will receive access to both the recording and all of the materials that we presented, all of the data, and also a summary of all of the Q&A, which we will conduct at the end of the presentation. As I'm going through the presentation, if you've got questions, I ask you to please submit them using the Q&A feature or the chat feature on Teams. Our team will be gathering all the questions that we received throughout the presentation, and we're going to respond to as many of them live as we can at the end of the presentation. But rest assured, all questions will be responded to and will be a part of the summary at the very end that you will receive. Okay, so let's get started. So just in terms of an agenda, we're going to cover 7 sections today, and I'll move through them relatively quickly. We'll start with just the basics of digestion, but in particular, why digestion of metal alloys and powders is especially difficult. We'll cover some of the limitations around the current methods that are being used, and we'll do some comparing and contrasting between ColdBlock sample digestion and a standard microwave digestion. We'll compare pros and cons of each method. And then we'll get into some of the data. We've gone through over many months and years, accumulated a library of many different CRMs, metal alloy and powder, metal powder CRMs, that we've completed sample method development, and we've gathered an enormous amount of data. We'll share some of that with you today. And we'll go through and we'll look at what does that data tell us? What are the more challenging alloy types that are out there? Which ones work with ColdBlock? Which ones don't? And then we'll draw some conclusions at the end here. And then, of course, at the very end, we'll go through some Q&A. So just to lay a foundation here, and I don't want to oversimplify any of this, but sample digestion is that process of dissolving a solid sample into liquid form so that it can then be homogeneous and be subsampled and analyzed on an analytical equipment such as an ICP OES or an ICP-MS. Standard process we're all very familiar with. Now, we're aware that an OES or a mass spec is really only able to analyze what is in solution, right? So if you're going through the sample digestion process and even a fraction of your sample remains undissolved or locked in solid form, that's going to be invisible to the instrument and you're not going to get great results. So sample digestion is really the foundation here. There isn't any calibration you can do to your equipment, no internal standard or technology or adjustments you can make that will compensate for a poor digestion. It is the single largest source of error in elemental analysis and has been our focus here at ColdBlock, providing technology that can offer excellent results repeatedly across a wide range of sample types. So let's just look at metal alloys and powders specifically. Why are these sample types difficult to digest? We're all aware of the passivation layers that can get created in chromium and aluminum and titanium bearing alloys, a protective oxide layer that is kind of by design, really. It's the same property that makes these metal types corrosion resistant. Is the same thing that's making them challenging to digest in the lab. We very similarly encounter regularly very refractory matrices, high alloy grades, ferrochrome, nickel superalloys. They all have very high melting points and very low chemical reactivity, and sometimes digestions can either be very slow or even not complete. Often you're dealing with powders as well. Metal powders have substantially larger surface area. They can react very quickly. Exothermic reactions can be frequent, and even though they react very quickly, that doesn't always mean you're getting a complete digestion if the acid chemistry isn't matched to that matrix. And then, of course, there's the volatiles. We are an open air system. Despite that fact, ColdBlock sample digestion still can provide excellent results on volatile elements. We do not lose those elements. They are reported alongside everything else. And we'll get into that in a second. So just on microwave itself, broadly, many of you on this call are using microwave digestion. It's a very proven, well-respected techniques, and for many labs, it's the right choice. Um, Despite that, and regardless of the types of sample that you're dealing with, you very often run into one of the four limitations that we've outlined here. The first is obviously sample size. Microwave digestion does have some real limitations on the maximum size that a sample size that can be used. If you're dealing with a fairly heterogeneous powder or coarse alloy chips, that can be a real problem from a sampling perspective. The second is probably capacity. Even some of the larger microwave digestion units that are out there have limitations on how many samples can be run at any one time. There's not a good scalability there. There are capacity limitations, and very often microwave is the bottleneck. Third is obviously that the digestion itself is taking place inside of a closed vessel. You can't see what's going on. You don't know if that digestion has failed until the end of the cycle. And then finally, we hear again and again from our customers that microwave demands attention. It's not just a capital intensive piece of equipment, they're also time intensive. They require constant monitoring during use. And even when they're not being used, there's a fairly regular and meaningful amount of maintenance and recalibration and cleaning processes that take up a considerable amount of time. Suffice it to say, when you are pressurizing acids, you are also introducing a safety component there that bears a certain level of attention as well. So ColdBlock digestion, again, our technology is now being used in labs around the world. We got our start in mining and moved into metal concentrates, and from there into soils and environmental sample types, and from there into recycling goods, e-wastes. And we're now doing some work in sectors like food and agriculture. The technology is now being used around the world. It addresses many of those issues that we've just outlined as it pertains to microwave. This is a technology that is offering a substantial improvement in terms of digestion cycle time, is very scalable and has incredibly high capacity, throughput capacity, given its speed and given the scalability of the technology. It is very simple. It is very safe. It's very easy to operate, easy to maintain, and our customers often report 2 to 3 times increase in capacity when they switch to ColdBlock. So what are we doing differently here? And again, I won't dwell on this. Many of you are aware of our technology now. We are using focused shortwave infrared as a means of delivering the energy. What does that mean? And why is that a benefit? Well, we can control very precisely the amount of infrared that's being delivered to a sample by sample by sample within our unit. They're all receiving exactly the same amount of shortwave infrared. So that repeatability is meaningfully better with our technology because we don't have some of the hot spots that you'll encounter, whether it's in a hot block or in a microwave system. And then that cooling zone that we have, our namesake, if you will, we're chilling the tops of the test tubes. There is a cooling zone there that is allowing a lot of the vapors that are from the boiling of the acid to recondense and pour back down. So we're retaining more of the acid. There is less acid being lost to the environment. We are retaining the volatile elements that you want to measure. So the cooling zone improves accuracy, certainly moderates a lot of the hyperboiling that's going on at the bottom of the tube, but then also adds a safety factor there as well. Our test tubes are cool at the top, and you can remove them and look at the digestion mid-cycle, if you will, so that there's a safety aspect to it as well. So side by side, ColdBlock versus microwave, I won't dwell on this. We've kind of drawn those conclusions. With ColdBlock, we are offering digestion times for the sample types we'll talk about today, 10 to 20 minutes, and compared with much longer microwave digestion times. We are able to run 16 samples in one of our medium-sized units, 20 in our small-sized unit, and those units are stackable and scalable, so much greater capacity improvements there. And we can handle sample sizes, certainly with the medium, up to 5-gram sample size versus half a gram in many of the micro systems that are out there. So all of those benefits on a side-by-side comparison. I won't spend a lot of time on this, but I guess the point of this slide is to show you that we aren't reinventing chemistry. We are using the same acids that you're using right now, and probably the same combinations of acids that you're used to using with your various sample types. The acid toolkit does not change here. We're all aware of what these acids are. We're all aware of the role that they each play differently in a sample digestion. We're not changing any of that when a switch to ColdBlock. And what we can show here and what you've seen, and this is probably very similar to what you're doing for each of these sample types as it stands right now. We've developed a method for each of them, and very often it's the same method, but little tweaks here and there. But we're just summarizing for you, if you will, the acids that you would be using for any of the matrices you see listed on the left. So let's get into a few of these. I'll start with Inconel 718. This is one of the most recognizable CRMs, if you will. It is a sample used, or a metal type used in turbine engines and jet components. It's known to be a very difficult a CRM or metal type to digest. As you can see in the table on the left, for all the key elements, we are recovering well within the range of accepted values. You can also see on the right, and we should have made that in a larger font size, to be honest with you, but the RSDs there are exceptionally low across the board, showing very excellent repeatability for each of those elements. Doesn't matter what day you run it on or what machine you run it in, the RSDs are exceptionally low across the board. And again, the digestion of Inconel 718 is completed with a ColdBlock in 20 minutes. Here we'll just look at wasp alloy. This is the results here are actually part of an independent study that was done by LGC Army. It's a nickel superalloy used in gas turbine engines. I guess the reason we would want to highlight this of all the different sample types that we looked at in this sector is really for what's not there. We were managing to do a full digestion of this sample type, and we were finding we could do it without including HF. I think traditionally and typically with the sample type, you would need to use HF. With ColdBlock, we're getting a full digestion in 10 minutes with no HF. And as you can see from the data on the left, exceptional results across all the elements that matter. Tungsten carbide and all the different secondary phases there. Probably one of the most chemically resistant engineering materials. What we're able to accomplish here with ColdBlock is really a complete open vessel acid dissolution. It's not, many considered that wasn't achievable until now with ColdBlock. So we were able to successfully get a complete digestion here. We're using nitric plus phosphoric acid. The infrared, cracks the tungsten carbide grain surfaces and attacks aggressively there. The HF was added really post digestion only in this case. So it's not a component or contributor to the digestion, but it's really being added as a stabilizing agent at the end to keep the elements in solution. So that's worth noting as well. So HF didn't dissolve the carbide. The phosphoric and the nitric did, and HF helped keep things in solution. So it's really the infrared heating that is doing a lot of the mechanical work there. No fusion, no high pressure microwave, no alkaline sinter, just a ColdBlock in 20 minutes, and they're tungsten carbide for you. A bit of a different format here, and again, we can provide data in any format you'd like across all of these CRMs, but here we're looking at 316L stainless steel powder, and this is more of a dot chart here, a dot plot. Each dot represents one separate measurement, per element. The orange vertical line is the certified value, and the green band is kind of a 2% window. So you can see tight clustering around that band. This is a challenging powder to digest. If you look at the major elements that are there, the dots are fairly well clustered around the certified number. But happy to provide this kind of data in this form for whatever CRM you'd like to look at. Just a bit of a summary here for the ferroalloys. We get asked about ferroalloys all the time, so it made sense to include something here. Ferromanganese, ferrosilicon, ferrochrome. These are all, you can see the results there. They kind of speak for themselves. Again, excellent recoveries compared with expected value, well within the range that you would expect of expected values for each of these CRMs, and exceptionally low RSDs across the board. I guess the one note that you can see in the footnote there, aluminum and magnesium recoveries for ferrochrome did fall below the range. Actually, you can see that on the next slide here. Excellent recoveries for all the elements at the top, but we're still working on optimizing this method for ferrochrome to improve on the aluminum and magnesium recoveries. I think we have a fairly good understanding as to why we're under recovering those, and we're working to optimize the method. But just to show you, this is all still, we are continuing to advance and expand our library of different methods. Here's a bit of a summary though for you. And you can see for all the ones listed in green there, it's obvious, and we can show you the data that supports the argument that ColdBlock is the strong choice here for each of those elements in dark green there. And we're happy to share data across the board here. There's obviously some that we're working on. We mentioned ferrochrome and under recovering a couple elements. We'll keep working on that. It works well for all the other elements, but certainly room for optimization. And there's some other ones on the bottom there that we haven't really done a lot of work on and are looking to get started on. So if you've got interest in those areas, let us know. We're always up for a challenge. So key takeaways, and just to wrap up a little bit here, I think what we can show, we're concluding based on all the work that we've done and work that our customers have done in this space, we can see ColdBlock as a superior alternative to microwave for most of the metal matrices that you're dealing with. More capacity and speed, and we've talked about that, but not having to go through pressurization of your acids, dealing with substantially lower maintenance and cleaning requirements, no need for regular recalibration, and all of that being accomplished in faster turnaround times with equivalent or better recovery and equivalent or better precision across the CRMs. I mean, 2 and 3, we can tie those two takeaways together because they're related. One is certainly ColdBlock's digestion cycle time is very fast. We are doing a lot of these in 10 to 20 minutes, titanium in 10 minutes. The speed really is coming not from changing the chemistry, it's coming from how ColdBlock works. Our heating and our cooling working together to retain the right amount of sample and have that reflux cycle happening and attacking the sample with the infrared the way we are is resulting in a fast digestion. And because we've built a unit that can stack and you can add multiple units and run them concurrently, the scalability with ColdBlock is just substantially better there as well. And then, of course, the volatiles. We didn't share any of the data here on volatile elements. Happy to share that with you if that's of concern for your lab and some of the samples that you're running. But retention and results on volatile elements is exceptional. I think we've shown that in some of our other webinars that we've presented over the last couple of years here. So we're keen to keep working, and we're keen to expand our number of partners in this industry who can look at ColdBlock as a viable alternative. We invite you to send us your samples and let us have a chance to run them in our lab and show you the results. But despite that, or even in addition to that, very often, regardless of the results we're sending to you, you're going to want to try ColdBlock in your own lab. And we've got lots of different avenues to do that. Our sales team would be more than happy to walk you through how you can get a ColdBlock into your lab relatively risk-free. Take it, try it, confirm that it does everything we've talked about here today. Confirm the economic and safety benefits of a switch to ColdBlock first, and then look at ownership and expansion within your operations. So I'm going to stop there and say thank you. I can see that we are gathering a number of questions in the queue here. What we're going to do right now is pause for just maybe a minute, gather up some of these questions, and then we will be right back and we'll get through all of them. Appreciate your attendance and your interest today and your questions today. We're excited to share these results with you. So bear with us just under a minute and we'll get back to this and go through these details and address all of your questions. So thank you.
Okay, thank you, Craig. We will start with the first question, which is, what happens to precision and recovery when you scale from 0.1 gram to 5 grams?
Thank you, Heather. Good question. Good one to start with here. I guess we think about a couple of things when we're looking at how we scale sample size. I mean, the first consideration is obviously reactivity. For reactive matrices like ferrochrome, we start with zero point 0.1 grams specifically to control, exothermic reaction that's there. Scaling that kind of a reaction when you're dealing with sulfuric, hydrofluoric, and nitric would probably be dangerous and methodologically wrong. The sample mass that we're digesting isn't arbitrary. It's kind of optimized for each matrix. For some of the less reactive matrices, nickel superalloys, stainless steels, titanium, there isn't any thermodynamic reason why you couldn't go and scale up to a larger sample size. Infrared heating with a cold block is consistent across the vessel, and the acid volume and scalability is absolutely there for sample size. I guess the other thing we'd think about is probably precision. When you're going from zero point 0.1 gram that you're typically using in a microwave to 5 grams, you probably, in some instances, could be improving the precision that you're getting. It's one of the key advantages of cold block over microwave. If you're dealing with a heterogeneous ferroalloy powder and where you've got some subsampling uncertainty kind of baked into the sample, going from half a gram to a 2 gram sample size is going to improve the data that you're getting out of that. It's going to improve the statistical representation, and your precision may actually go up. Now, when you're scaling sample size from zero point 0.1 to 2 to 5 grams, there's obviously some work that would have to be done there. No different from if you were scaling up sample size in a microwave or in a hot block. You would go back and you would reassess, acid volumes to be required, digestion times, power settings, all of those things you would go through as you're developing a method for varying sample sizes. So it is a process, but with cold block, it's a very straightforward and simple process.
Okay, another question. Can cold block work effectively for copper ores and concentrates?
Okay. Yeah. I mean, we can talk about that. It's a little bit off topic from today, but yeah, we kind of got our start in mining and mining sample types and concentrates. We did a lot of work in that area. You can see on our webpage a number of different application notes dealing specifically with those sample types. It's kind of absolutely within our wheelhouse. It's kind of where we got our start. We've had a very meaningful uptick in interest in cold block for those sample types, just given the amount of trade flow that happens and the need for fast turnaround times. Cold block fits in there quite nicely, and happy to provide additional information there on methodology after the webinar.
Great, thank you. Another question. Can you talk about the specific ICP OES measurements, wavelength selection, spectral interferences, and how you handled high chromium and high tungsten matrices analytically?
Wow. Okay. That we could probably have a completely separate webinar on that topic. Great question. Obviously, when you're dealing with high chromium matrices, that's a spectral nightmare. I mean, chromium has over 1,000 emission lines, and when you're measuring vanadium, manganese, phosphorus, you're trying to find a needle in a haystack here, and where the haystack is made of needles, it's a challenge. Obviously, tungsten, same thing. Probably makes chromium look simple. We could spend a whole day on wavelength selection there. Um, we can get into those details at a little day. What I'll say is this: the analysis and all the associated considerations on the setup of an OES or an ICP-MS, all of those considerations are the same with cold block as you're currently experiencing with microwave or hot block. There aren't any real differences with cold block in how you're dealing with the analysis. We're approaching this the same way you would right now, with matrix matching and matching the acids and making sure that the dominant elements, chromium, iron, tungsten, are at realistic concentrations as we're calibrating solutions. We're dealing with it the same way you're dealing with it right now. That's obviously a lot more that could be talked about there, and happy to get into that. Maybe we'll have to have another webinar at a later date to kind of go through that topic.
Okay, another question, Craig. Can you share any real-world examples or feedback from labs in the metal powders and alloy space that have integrated cold block into their operations?
Yeah, sure. I mean, like I said at the beginning, we've been working in this sample type for some time now, for several years. I think one great example is probably Höganäs. It's a Swedish company. It's recognized as one of the leading producers of metal powders, and they're members of the Swedish Steel Institute. After integrating ColdBlock into their workflow, they were reporting benefits, for several areas: speed, certainly, safety, data quality. They were mentioning how their digestion times were dropping significantly, and that was resulting in an improved throughput without having any impact on accuracy. They also noted, reduced acid volumes and fume exposure, which is obviously a win for the lab on the safety side of things. As a precision manufacturer, trace and major element recoveries matters absolutely to them. I think there's actually a testimonial on our webpage from a couple of years ago. I think it's May 2024. There's a testimonial on the webpage from Hogana, so you can hear directly. But yeah, we have several real world examples. That's a good one of a customer that's been using the technology for some time now.
Great.
Other questions? We have time for one more, or?
Nope.
Okay. Why don't we cut it off there? I mean, we typically find with our webinars at ColdBlock that questions continue to flow in for an hour or two after the call. Please submit if you aren't able to submit a question on the webinar right now, please feel free to email us at info@coldblock.ca. We will incorporate that into the materials that we'll compile and send around to all participants here today. So we'll ensure all questions get answered. Happy to have spent the time with you today to talk a little bit about this sector and some of the work we've done there. We're excited about the data. We see ColdBlock as a real valid alternative to some of the digestion technologies that are out there right now, with real clear benefits across the board, as we've discussed on the webinar today. Why don't we leave things there? Again, appreciate your time today. Thank you for joining us.